I'm going to show you what happens with two terms when it comes to graphs. One of the terms is translation. And in order to translate it, you usually give a coordinate that you want it moved around. For example, if we were to translate this triangle in the coordinates 2, 1, we know that the 2 means what happens in the x direction. And we know that the 1 means what happens in the y direction. And it basically means that we move all of these coordinates on this triangle, 2 along and 1 up. So this point here that is at the moment at -4, 1, would move 2 along, 1, 2, and 1 up. So it would end up being at -2, 2. This point that is here is at the moment at -4, 5. It's going to move 2 along, which would take it to -2, and it's going to go up 1, so it would end up at -2, 6. This coordinate is at -1, 5 at the moment. It would go 2 along, so it would go over to the positive side. It would go to +1, and then it would go up 1, so it would be at +1. +1, 6. And if we look, it's exactly the same shape of triangle. There's absolutely no size change. We haven't scaled it up or anything else like that. We've still got a right angle if I'd drawn it a bit better. You see it's the same triangle, just shifted. 2 along and 1 up. And that's called a translation. Okay? Translation is just we've moved it. And we move every coordinate the same amount of steps. I can leave that there so you can see it, even though it's not. It should really be -2. So here should go up like that. But then they can also tell you to reflect the triangle around the y-axis. And what do they want you to do then? Well, in a way, you can think of it as they're asking you to draw a perpendicular line between this point and the axis that you're rotating it around. It's almost like you can imagine us reflecting it around there. If we turned it around, where would it end up? Exactly the same point on the y-axis, but if it's -4 here, it's going to end up being +4 over here. So it's the same distance of, here is the distance along the x-axis of 4. We have exactly the same distance of 4 on the y-axis. Okay? So that was that point, and then we would do the same thing for the next point. Here we have a distance of 4, but at the point +5 in the y-axis. So we would make the same distance on the other side. So we'd have the distance of 4 again, but at x equals 5. So this distance is the same as this distance. 4 here and 4 here. So we always have exactly the same distance. You have to think of it as being a perpendicular line. You're writing a line at, drawing a line at right angles from that point through wherever you're reflecting it to the other side. What about this point then? Well, this point is only 1 point away from the y-axis. So it's only going to end up being 1 point away from the y-axis here as well. And then we finish off by drawing our triangle. Which we can see if I'd drawn it as straight lines. This triangle is an exact reflection, it's a mirror image of this triangle. And we often call it T prime. T with a dash on the top, that is like the mirror image. Okay? So that's how we do a reflection around the y-axis. If we have a little look at what coordinates did we end up with? Well, here we had -4, 1. Here we end up with 4, 1. So the y stays the same, but the minus turns into a plus. Here we had -4, 5. Here we end up with 4, 5 as our coordinates. Here we have -1, 5. Here we end up as 1, 5 as our coordinate. So notice that the x coordinate goes from being negative in a number to being positive. So you're changing the sign. but the y-axis stays the same, the y-coordinate. Here, the -4 in the x-coordinate turned into the +4 here, but the y stayed the same. So when you do a rotation about the y-axis, the y-coordinate stays the same, and the x-coordinate just changes sign. So you don't actually have to do all of this drawing if you know that technique. You can just plot your coordinates on the other side of the graph. -x turns into +x, y stays the same. So that's if we were going to mirror image around the y-axis. Reflection.